Welcome back, everyone. So now let's go ahead and do some more practice problems where we write the balanced chemical formula for an ionic compound. That's something that has a metal and a non-metal. So in these four examples that we're going to talk through, I was nice in the fact that I gave you the charges for the associated cation and anion. Now, on exams, I'm not going to be as nice. You're going to need to know that, oh, calcium, yeah, calcium, when it's in an ionic compound, well, its symbol is Ca, but it has a +2 charge. Chlorine, chlorine in an ionic compound, since it's in group 7, since it's a halogen, it has a -1 charge. So first point from this slide before we even do any, before we solve any of these problems, is that when writing ionic compounds, you should not assume that I will give you the symbol and charge of that element. I may just give you the name and you have to write the formula. And we're going to talk about how to name compounds shortly. But for this example, I was nice. So let's go ahead and practice that skill of taking cations and anions and putting them together to form a neutral molecule. And when we say neutral molecule, that means the overall charge of that molecule must be 0. So for calcium and chlorine to come together and form a neutral molecule, since each calcium's a +2 and each chlorine's a -1, I'm going to need 1 calcium and 2 chlorines in my compound. And remember, when we put ions together to form molecules, subscripts, always subscripts to designate number of atom. If you just have one of that atom, no subscript is needed. Okay, so CaCl2 would be calcium chloride. Got a little bit ahead of myself with the iron and the oxygen. Since iron is a +3 and oxygen is a -2, for my charges to equal out, I need to have 2 irons and 3 oxygens. So this part of the molecule is now a +6. The oxygen is a -6. And so now our charge is equal to 0. We talked about in a previous video how a quick and dirty way to write ionic compounds, especially if you have ions that aren't, that aren't the same or have a charge that's other than -1. You can do that little crisscross applesauce where the numeric charge on one becomes the subscript on the other, and vice versa. So that's another way you can kind of check yourself. For this next example, I have barium and nitrate. And so looking at this, you see that, oh, I'm going to need 2 NO3s, 2 nitrates. When writing that corresponding formula, anytime you have more than one polyatomic ion, and nitrate is a polyatomic because there's more than one element here, anytime you need more than one polyatomic, you must use parentheses. If I just put a 2 out by the NO3, it would be not very clear as to how many of that species I had. So to clearly designate that I have 2 of the entire polyatomic NO3s, use parentheses. And in the last case, we're going to need to use parentheses as well. In this case, for the ammonium, we're going to need 3 NH4s and just 1 phosphate. So again, you should feel comfortable being able to write ionic compounds with using those skills. You should be able to do that by also remembering the symbol for an element as well as its charge. I could have just easily said, like for A, what is the formula for the species formed by calcium ions and chloride ions? So that's the end of this little vignette. In the next videos, we're going to dive more in detail as to how to name ionic and molecular compounds.